Okay, guys, word problem review. Let's look at them and try them. Example 1. If you remember, my step 1 is always read the problem. That is a beneficial step 1. So, Boyle's law says if the temperature of a quantity of ideal gas is unchanged, the product of the pressure and the volume equals a constant K. When there are 1,000 cubic meters of a particular ideal gas, the pressure is 5 newtons per meter squared. What would the pressure be if the volume were 200 cubic meters, assuming the temperature is the same? Okay, so yeah, this is where we start rereading it and trying to gather all the information, right? So, and there is, now here's the deal. You may know a formula off the top of your head. However, this is not a formula I would expect that would be required to be known in calculus. Okay, this is something they provided somehow or another. The formula is there. You just have to read. Boyle's law says if the temperature of ideal gas is unchanged, the what? Product of pressure and volume equals a constant K. Did you catch that? The product of pressure and volume, so P times V, equals a constant K. So we have an equation to work with. Okay. When there are 1,000 cubic meters, is that pressure, volume, or a constant K? Volume, right? You should know that volume is measured as a cubic, right? As a power to the third. So this is a volume. When there are 1,000 cubic meters of a particular gas, the pressure, so that tells you, right, is 5. So right there we know a volume and a pressure. Then it says what would the pressure be if the volume were 200. So let's go with what we know here. The volume is 1,000, the pressure is 5. What are we going to do with those? Yeah, we're going to fill those into the equation and multiply. So pressure of 5 times volume of 1,000. 5 times 1,000 is 5,000. So we just found for this particular problem our constant K to be 5,000. Now it's asking what would the pressure be? So what would the pressure be if the volume were 200 cubic meters? And notice it says assuming the temperature is the same. So what am I going to do here? What? Yeah, we're going to change our volume. We're using the K. Yep. Yeah. We're trying to find pressure. My new volume is 200, and we're using that 5,000 as our K. So if we find P, it's P times 200, so we're going to divide by 200, 5,000 divided by 200. We'll cancel the zeros, and it really becomes 50 divided by 2. Now I can do that mental math. 50 divided by 2 is 25. 25 what? Yeah. And it's okay, even if you've never dealt with pressure, you don't know the label. Didn't they give it to us? So 25 newtons per meter squared. Questions there? May not have been the greatest problem, but it wasn't, it wasn't horrible. Okay, example 2 if you're ready. Dagny and Lale found that the cost varied directly with the number who worked and inversely with the Sabercat index. The cost was $400 when 5 people worked and the index was 8. What was the cost when 13 people worked and the index was 2? Okay, I did step 1. I read the question, right? Kind of like last time. Can you rewrite it? Or can you reread it and find like an equation in there? They found that the cost varied directly with the number who worked and inversely with the Sabercat index. Do you remember doing direct and inverse variation?
Yes, but I couldn't say that.
Okay. And if you want a side note here, with direct variation, it is always y equals kx. If something varied for direct variation, we multiplied by a constant. If something was inverse variation, we didn't multiply by a constant, but we divided. We didn't divide by the constant, but we do the constant divided by the variable. Does that sound a little familiar? Okay, so that's kind of necessary. You need to know that direct variation, it's the constant times the variable. Inverse variation, it's the constant divided by the variable. And so now, okay, cost. What do we want to use for cost? I'm going to say C. So C varied directly. When it says, starts off that way, to me that says C equals. Cost varied directly with number who worked. I think number who worked, I've used W in the past. So if it's with the number who cost varied directly with the number who worked, that's going to be C equals K times W, because that's direct variation. So it's a constant times a variable. And then it says inversely with the Sabercat index. I'm going to use S for the Sabercat index. Since it varies inversely, we're going to divide by S. You only need one constant in this type of problem. Okay, you don't need a problem every time it says or a constant every time it varies. You just need one variable or one constant there. So this is the formula we're using. Are you guys okay with that formula? Now that I've walked you through it at least? Okay. Cost, varied directly, so it kind of says equals. It also says we're going to multiply by K. So it varies directly with the number who worked. So I did K times W. And then it varies inversely. So we already have the problem started. Inversely with the Sabercat, so we're dividing by S. Okay. The cost was 400, so that's a C value, when 5 people worked. That's a W value. And the index was 8, which is a Sabercat value. They've given me a C, W, and S that all work together. I can use those to find what? Okay, you find your constant for the problem. So, what did I say? 400 equals K times 5 divided by 8. I personally see it as divide by 8, so I'm going to multiply by 8. So then I have 3,200 equals 5K. Divide by 5. And K is 640, I believe. Okay, so that's the K value we're going to use now. Okay, doing these type of problems, when you did these as far back as Algebra 2 at least, they give you all the information so you can find the variable the first time through. And then the next time you will, work to find a missing piece of information. So now it says, what was the cost? So I'm trying to find the cost when 13 people worked and the index was 2. So what was the cost? C equals K times W over S. So K we came up with 640. 13 people worked and the index is 2. Do the math. And you get Did you get 4,160? Did anyone do the math? Not really. Did you do it, Kaylee?
Yeah.
Okay.
I do it in my head. Sorry.
Could you do this one in your head?
Yeah, if I really, really tried.
Okay. I mean, for me, I can look at, okay, 640 divided by 2 is 320. And then I'm down to doing 320 times 13. Which, if I work hard enough, it's doable in my head, but...
Yeah, but you said that there's not, the portion of people have calculators,
Right. Yeah. Now, on something like that, in all honesty, if I'm doing that on a test, I'm going to do 640 divided by 2 in my head, probably. I know that's 320, but then I'm going to grab a pencil and I'm going to say, yeah, I need to write that down, you know. Hey, guess what? It works out. You know, yes, you still need to be able to do that multiplication on occasion, right? You know, that's not horrible. That's doable. Okay. And this is officially 4,160 what? Dollars, because it was cost. So, yeah. And the ones I'll push you on more than anything is like, you know, we're doing the like fractions and stuff. I'll push you to try and not just go straight for the calculator. So, okay, you ready for C? The cost varied linearly with the number of workers. When there were 10 workers, the cost was 70. When there were 20 workers, the cost was 120. What was the cost when there were only 2 workers? So this one's a little different. I don't know necessarily how much you've done something like this. I'm trying to remember. So it's the cost varied linearly with the number of workers. Well, you can take a guess. Cost, I'm going to use C. Number of workers, I'm going to use W. If you want to use N, it's, you know, whatever floats your boat there. It varied linearly. What comes to mind when you think linearly? Okay. What comes to my mind also is Y equals MX plus B. Now, we're not really using, I mean, you need to go one way or the other. You can use Y and X as your 2 variables, or we can switch over and call them C and W. Okay, now if you remember with Y and X, X is the x-axis, right, the horizontal axis. That is your independent variable. And then Y is dependent on that, right? So as we look at this, the cost varies linearly with the number of workers. This cost is going to be dependent on the number of workers, right? You have to know the number of workers to find the cost. And so in that case, Y equals MX plus B. My Y, is going to be replaced with C. So C equals MW plus B is going to be the equivalent of what I'm looking at. Again, if you prefer to work with Y and X, you can do that too. Now, it's an equation. Looks like a line, right? Think about ordered pairs. When there were 10 workers, the cost was $70. So what's that ordered pair look like? 10,70, I believe. Yeah. Because worker, you know, the cost is dependent on workers. And then there's another ordered pair you can be given, yes? 2120. Oops. 20 workers, $120.
Then we're gonna use that to find the slope.
Yes, you can. Not how I traditionally do it, which is why I was just processing. Okay, so you guys heard Ross's comment. He said we can use those to find the slope. Yes? You can use those to find slope and y-intercept, right? Okay, that's not what I was thinking about doing, which is why, but that makes perfect sense. I'm not arguing it either. Okay, it makes perfect sense. It works out. I was doing something slightly different, and it actually works out to be more like an elimination technique. Now, I'm trying to think, over the years, why have I done it this way? And I'm guessing it's the book did it this way. Okay, but yes, you could use those, find the slope, and then use those to find B, find your y-intercept. What I had actually done is using this equation here, filling in the two ordered pairs, and finding the M and B this way. So what I've done is 70 equals 10M plus B, and 120 equals 20M plus B. I'm guessing you guys are going to like your other way better because you already know it. So, and the idea I think of is, okay, two equations, two unknowns. You can think like elimination or substitution to do this. And that's what I've done in the past. As I said, why have I done it that way as opposed to just finding slope? I'm not sure. Maybe this one carries over more to everything else. That's probably what I need to be saying here. Okay, so what happens if you subtract these equations from each other? Remember elimination? It's B and B, right? If I subtract those equations from each other, notice the B is going to cancel. 70 minus 120 is negative 50, 10M minus 20M, negative 10M, B minus B cancels. At that point, what do we find our M to be? 5. Which, if you went the direction of just finding slope earlier, that worked as well, didn't it? How do I find B? Yeah, plug that 5 in to one of your original equations. So 70 equals 10 times 5 plus B. 70 equals 50 plus B. And B is 20. So I can write my equation now. It was C equals MW plus B. Now it's C equals 5W plus 20. You keep wanting to reverse the numbers back there.
Yeah, I swear I'm just
Okay. And then what was the actual question we were being asked? Okay, what is the cost when W is 2? So $30. Okay, you got it? By all means, if you want to go back and find the slope the old way on that one, that's fine. However, given a non-slopey situation, where it's something different, this technique also works. So, okay, example 4. To me, example 4 is one of those peek ahead at calculus type things. Okay, I mentioned yesterday that the Saxon book kind of likes to preview upcoming events, I feel like. This is one of those things they're trying to preview. Okay, this is a skill you need for something else later on down the road. So just kind of beware there. Farmer Jill wants to use 100 meters of fence to enclose a rectangular region that borders a river. If L is the length of the side of fence parallel to the river, what is the area of the fenced region in terms of L? Assume the river's border is straight and no fence is needed along the river. Okay? Now, I like to draw a picture on this one to get us started. We have a rectangular region, right? And it borders a river. I know the river's straight, but if I make it straight, you can't tell it's a river, can you? So there's my river on the top part. Maybe you can't even tell that's a river, but just pretend. Okay? We know she has 100 meters of fence. It says L is the length of side fence parallel to the river. So it says that side is L. And by the way, if that's the length, what do you normally call the other sides? These are widths, right? Okay. Now, if L is the length of the side, the fence parallel, what is the area in terms of L? Now, what comes to your brain when we talk area? Length times width, yes? And it says it wants the area in terms of L. Now, for the length, we are using, I wrote lowercase l and w out of habit. For the length, we are officially using big L, aren't we? For the width, are we allowed to use a W? No, we want it in terms of L. So, let's go back to our drawing over here. We need to use this information here to come up with an equation that connects L and W. We're looking for an equation that connects the length and the width. So based on this information over here, what connects the length of, what's an equation that connects the length and width? She's fencing 3 sides of the region.
Okay, so one L plus 2W has to be 4 meters.
Yep, because she's fencing the 3 sides, so we ignore the river side, and she's going to use 100 meters to do that, right? So now we're kind of talking perimeter, aren't we? Except it's perimeter of only 3 sides. So yes, think of 1L plus 2W equals 100 meters. Okay, that's the key to doing this problem, is looking for what's an equation that connects L and W in the same equation. Because now what I can do, I need something over here to put in for W that's in terms of L. We can take this equation here that connects L and W, solve for W, and it'll be in terms of L, and we can put it over here. You see where I'm going with that? Okay, so solve this guy for W. If it's L plus 2W, first thing we're going to do is subtract the L over. So then I have 2W equals 100 minus L. And then I'm going to divide by 2. And I have 100 minus L divided by 2. You can leave your W like that, or you could say 50 minus L over 2. Okay? Either is fine. Now, what do we have here? We have a W, yes? So W equals this. Can I put that in here? Yeah, right here is length times W. I need W. So W is 100 minus L over 2. And so now I officially have written an expression for the area in terms of L. All you can do past here is you can do some cleanup. There's not just one right way to express this. So if I distribute the L, that L is going to multiply through on the top, right? It's like L over 1. So I'm going to say 100L minus L squared all over 2. And then you can also split that. I knew someone had. Okay, so 100L divided by 2 could be written as 50L minus L squared over 2 is just L squared over 2. Okay, if you don't like L squared over 2, you could say 50L minus 1/2 L squared. Those are all possible expressions. Honestly, any of those last 3 could be good depending on the situation. Okay. I have the last 2 boxed, but honestly, this one's a good one too. Depending on the situation of what you're trying to do afterwards. Okay? So, do me a favor. Don't just skip over these problems every time. Work to get them figured out as we go through these, okay? Because this is one of those prelude to upcoming events. This will be necessary part of a problem. Okay? So, it takes practice. And I say that was my last problem, wasn't it? Yes. Okay. One thing before I shut off the recording, because I'm hoping Maddie's probably going to be listening to the recordings too, so this way she can hear what I'm going to say. The page we skipped over to get here. Okay. First of all, there was kind of a formula page, yes? Those are just some good formulas to be familiar with, to review. Or when you get 10 lessons down the road, you're like, oh, I don't remember that identity. This is up here, right? Remember, this page is up here. There's the same unit circle we used last year, right? Look at after lesson 5 real quick. There are, 3 pages? I don't know. Miss Byers had done these notes when she was here. And there are just some good handy formulas there. Things that aren't necessarily provided that you need to be familiar with. Okay? We talked about volume the other day in here, didn't we? I think it was in calculus. So, there's some volume information. There's surface area information. There's some various things about polygons, about circles, areas, perimeter, circumference. As we go through the year in calculus, you'll always have your notes with you, so those are good resources. Okay? Just kind of be aware of that. Okay, you guys know problem set 5 is homework. And normally, once we get into this, we would have stopped after problem set 4. We'd have a review day today, and we'd have a test on Monday. Okay? The way we're going to do this for the first set is after problem set 8. We'll have a review day, and then a test. Okay? So we'll talk more about that next week. But I think I figured it up yesterday, didn't I? The test is going to be next Friday, I think, if we stay on track. So, okay.